We're going to be talking about linear and absolute uh, inequalities today. And we're going to first, again, review what an inequality is and how it would look like. And start with the most basic one, the linear ones, and talk about maybe a new way of graphing them, and then what interval notation is. You've used interval notation before when talking about domain and range, so all of those rules are still going to apply. So x is greater than or equal to a. What that would look like in a graph, if we had a right here, it would be a closed circle, and we would be going to the right, all the values, x values that are greater than a. Now, if x is by itself, or if your variable is by itself on the left side, the arrow of the inequality sign tells you which way you're going to graph. Again, it's only true if you have the variable by itself and on the left side. So then x is less than or equal to a, again in closed circle, and going back this way. We'll talk about the new way in interval notation after we go through all of these. X is greater than a. Well, the only difference between that and the purple one is the equal part underneath. So this is going to look just like the first one, but instead of a closed circle at a, it's going to be an open circle and everything greater than that. And then similarly, open circle and going this way. So these are what we would call unbounded, because we go all the way in one direction forever. So they are unbounded. Now, these ones down here, these are called bounded ones because we don't go forever in both directions. So for these, it says we have A and B for both of them. And it says x is greater than or equal to a. So if we start at a with a closed circle, we go this way. But also less than or equal to b. So at b, we have a closed circle and going to the left. So my x value has to be within that a to b range. It has to be in between them. Now this is the same idea, but with open circles. So that's the way you learned how to do it in Algebra 1 and in other math classes. Now we're going to talk about a new way, and the new way of doing these, it uses the same symbols for interval notation. When we were talking about domain and range, if we wanted to say all values greater than or equal to a, we would say a comma infinity with a bracket because it was included or closed, and an open and a parenthesis for infinity, or if it doesn't include that value. Okay, and infinity always has parentheses. So what we would do is we still have a, but instead of a circle, we would do a bracket because it's included. And then for this one, okay, so we have our a value, and it goes to the left, and at a we have a bracket, and then our interval notation for this one would be ne infinity comma a. So it just, this new way of drawing them just coincides or use the same symbol as our interval notation, so it helps us with using the correct symbols for interval notation. Okay, this one, same idea. We have a, and instead of putting an open circle there, we're going to put a parenthesis because a is not included. So our intervals from our intervals from a to positive infinity. In this one, we have a and a parenthesis. Sorry, not parenthesis. Sorry, it is a parenthesis, but I drew a bracket. A parenthesis, and going this way. So negative infinity, comma a. And then these bounded ones. Okay, so we have a and b. And we want everything in between a and b, including a and b, so we're going to put brackets, and then everything in between. We have a comma b with brackets. And then the same thing here, but instead of brackets, parentheses, because in this one we had open circles, or they were not included. So everything between a and b, not including a and b. So here we're going to graph each inequality and the right interval notation as well for the inequality. So we have x is greater than 7 but less than or equal to 6. So negative 7, 6. Now it's greater than 7, so parenthesis, but less than or equal to 6, so a bracket. So it would look like this, and then negative 7, comma 6. So you can see how using this different way of graphing the inequality will help us write our solution in interval notation. Okay. X is less than or equal to 4. So here's 4, and less than or equal to would be a bracket, and going less than. So then it's going to be negative infinity, comma 4 with a bracket around 4. And then x is greater than negative 2. So again, we're going to draw, right, negative 2. Now, greater than means just a parenthesis, because negative 2 is not included. So parenthesis negative 2, comma infinity. Now, solving inequalities. This is sometimes a little bit tricky because we really have three sides. We have the left side, the middle side, and then the right side. So we're still going to try to get x by itself, so we're going to add 8, but we're adding 8 to every side. So now it's going to become 5 is greater than or equal to negative 5x, which is less than or equal to 10. Now if you divide everything by negative 5. Okay. When dividing by a negative number, we flip the inequality sign. So when dividing by a negative number, flip inequality sign. Inequality sign. So now it's going to become negative 1 is greater than or equal to x, which is greater than or equal to negative 2. Now, we usually, when we're doing domain and range or writing interval notation or graphing inequalities, we want the smallest number on the left and the biggest number on the right. But right now, that's reversed because negative 1 is bigger than negative 2. So watch what I'm going to do. I'm going to flip them. So I'm going to put negative 2 first because it's smaller. But my inequality sign is x is greater than or equal to negative 2. So you see how x. So you see how I flipped that, but it meant the same thing. Okay. we have right here x is greater than or equal to -2, and here the open part of the inequality, the x is greater than or equal to -2. But we also just say that x is less than -1. So yes, this changed again, and the reason again we're changing that is because we want the inequality to be written in order. The left number is the smallest, the right end is the largest, because now that's going to make graphing this a lot easier. So we have -2, -1. X is greater than that, greater than or equal to, so we're going to do bracket, but less than -1. So it's going to be everything in between. So I know that can be a little bit confusing, so you just got to be very careful that when you're moving your signs around, that you're still saying the same thing. Right now, on the next page, we're going to talk about absolute value inequalities. Because remember, absolute value means the distance away from 0. So if I say that the absolute value of x is less than 5, what that means is that the distance x is from 0 is less than 5 units, but that could be on either side. Because if we look at a number line, okay, there's 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So anything in this range has a distance from 0 less than 5. Because if there's my 0, okay, -4, that distance from 0 is 4, which is less than 5. So what we have to do with absolute value, just like how in solving absolute value we had two equations, for inequalities we would have two inequalities. We would have one that's x is less than 5, but then one that x is greater than -5, because that would give us a distance that is less than 5 away from 0. And we would have to write this as -5, 5. Now here, absolute value of x is greater than 5. That means the distance from 0 is greater than 5. So if we have our number line here, we want everything outside. We want this way, because all those numbers, yes, they're smaller numbers, -6, -7, so on, but the distance away from 0 is bigger than 5. So we'd want x is less than -5, but also everything over here where x is greater than 5. So you can when we solve the absolute value equations, we said the absolute value of x was equal to 5. We would say x is equal to -5, and x is equal to 5. We do the same thing. We would have a positive one and a negative one, but notice for the negative one, we switched the signs. So our answer here, our solution, is going to be -infinity, -5, and the way we write and in symbols is this U, which stands for union, 5 to infinity. So this means and. So our solutions are from -infinity to -5 and 5 to +infinity. So if we look down here, we have some examples. First step is always to isolate the absolute value, get it by itself, and then we're going to switch it to two equations, one positive and one negative, but for the negative one you have to flip the sign. So we have 3x plus 4 is greater than 6, and then 3x plus 4 is less than -6. And then you'd have to solve these. All right, in purple we get 3x equals 2, or sorry, not equals, 3x is greater than 2, then x is greater than 2/3. And then the blue one, subtract 4 from each side. 3x is less than negative 10. Divide both sides by 3. 3 is less than negative 10/3. So then on our number line, we have negative 10/3 and positive 2/3. And it says this should say x. X is less than negative 2/3. So parenthesis, and everything smaller than negative 2/3. And then x is greater than 2/3. So here's 2/3, parenthesis, everything bigger than that. So we would say from negative infinity to negative 10/3 with parentheses and 2/3 comma infinity. This one, the absolute value is not by itself, so the first thing we have to do is add 4 to both sides, and we get the absolute value of 11 minus 2x is less than 3. Now we can split this up into our two inequalities. Whoops, this one should be greater than negative. So we're going to solve the purple one, subtract 11 from both sides, so negative 2x is less than 3 minus 11 is negative 8. Divide both sides by negative 2, we get x is greater than 4. Then for the green one, subtract 11 from both sides, we get negative 2x is greater than negative 14. Divide both sides by negative 2, x is less than positive 7. Because remember, when you divide by a negative sign, or negative number, you flip the inequality sign. So then 4 and 7. We have x is greater than 4. So here's 4, parenthesis, and greater, so everything bigger, but x is less than 7, so parenthesis at 7, and going to the left. So our solution, our interval, is 4, 7. All right, then let's get the third one. We have 2 times the absolute value of 2x plus 3 is less than or equal to 6. So divide both sides by positive 2. So this one has less than or equal to, so when we graph them, we're going to use brackets, and when we write our answer in interval notation, we're also going to use brackets. All right, so now we have 2x plus 3 is less than or equal to 3. And then we have 2x plus 3 is greater than or equal to negative 3. So we have 2x is less than or equal to 0 once we subtract 3 from both sides. X is less than or equal to 0. And then over here we have 2x is greater than or equal to negative 6 when we subtract 3 from both sides. And that gives us x is greater than or equal to negative 3. So we're going to draw our graph. We have negative 3, and we have 0. So we have x is greater than or equal to negative 3, so a bracket at negative 3, and we want everything bigger than that. But then we have x is less than or equal to 0, so bracket at 0 and everything less than that. So we have negative 3, 0 as our answer. All right, so last one, we have to get the absolute value bar by itself, so we'll subtract 4 from both sides. So we have the absolute value of 2 over 5x minus 8 is greater than or equal to 8. Now that the absolute value bar is by itself, we can split this up. And then the second one is going to be 2 over 5x minus 8 is less than or equal to negative 8. Right, so then we will solve these. The blue one, add 8 to both sides, so 2 over 5x is greater than or equal to 16. Well, then we have to multiply both sides by the reciprocal, 5 over 2. And when we do that, on the left side, we get just x is greater than or equal to, and then 16 times 5 over 2 is 40 if we type that in the calculator. So x is greater than or equal to 40. Now the red one, add 8 to both sides, 2 over 5x is less than or equal to 0. Well, that's nice because when we multiply both sides by 5 over 2, we're still going to get 0. So now on our number line, this one's going to look different. We have 0 and 40, and x is less than or equal to 0, so bracket, but anything smaller than 0, and x is greater than or equal to 40, so anything 40 or bigger. So we have a range on the inside that x cannot be, but we are unbounded on the outside. So we have negative infinity, comma 0 with a bracket, and then 40, comma infinity with a bracket around 40. So I know that this new way of drawing these inequalities is a little bit confusing, but you're going to get to the point where you won't even have to draw them. And drawing them does help you make sure you're using the correct symbols when we write our answer in interval notation. One last thing, we have to put that U in there for the union, like both of those things could be true. Right? So thanks for watching. Make sure to like the video and subscribe.